Welcome back to our first unit in grade 9 math, number sense and algebra, and today we're going to be starting our second lesson, which is the basic exponent laws. Some of you know what exponent laws are and some of you don't. Well, that's perfectly fine if you're either one of those two people, but today I'm going to be teaching you what exponent laws are, when they're applied, and the different types of exponent laws as well. So without further ado, let's get right into it. So the first exponent law is the product exponent law. Well, some of you may be asking, what is the product exponent law? The product exponent law is basically the exponent law used when you are multiplying two exponents. And an exponent is basically something that has a power other than 1. So a to the power of 2 is an exponent, as it has a power of 2. See, this is a power. A power is basically when something is multiplied by itself so and so times. So when I say a to the power of 2, I mean that a is multiplied by itself 2 times. So it's going to be a times a. A is multiplied by a 2 times. So the product exponent law works when you have two exponents, both with the same base. So for example, we have a squared times a cubed. As you can see, both of these exponents have the same base of a over here, and we can use the product exponent law to simplify this big term over here into something as simple as a to the power of 5. Well, some of you are asking why, how did you actually do that? Well, the product exponent law works as when there's two exponents that are multiplying that are being multiplied together, you can simply just add both the powers, which in this case is 2 and 3. So a to the power of 2 plus 3 is equal to a to the power of 5, of course. So you're saying that basically this entire equation right here is equal to this entire equation. As when you're multiplying two exponents with the same base, of course, of a, you can simply just add both of their powers to get a simplified product exponent. So let's try this with real numbers. So let's say 2 to the power of 2, same thing, 2 to the power of 2 times 2 to the power of 3. So we can say that 2 to the power of 2 times 2 to the power of 3 can be simplified further as 4. So as of right now, we're just solving it normally rather than using the product exponent law, which would be used like this, like right now. But instead, we're solving it first and then applying the product exponent law after to verify if it makes sense or not. So 2 to the power of 2, which is 4, times 2 to the power of 3, which is 8. So you get an answer of 32. So when you simplify this using just normal algebra, you get an answer of 32. However, when you use the exponent law, we know that 2 to the power of 2 times 2 to the power of 3, sorry about that, the power over here, that's 2 to the power of 3, is simply equal to the 2 to the power of 5. And we know that 2 to the power of 5 is 2 times 2, how many times? Well, 5 times. So I'm going to punch it into my calculator right here. So 2 to the power of 5 is also equal to 32. This makes sure that even if we solve it using algebra or the exponent law, both of them work. But the exponent law is just a lot simpler and easier way to simplify exponents. So let's move on to the next exponent law. Just like product, we have the quotient exponent law. Quotient is a pretty big word, but don't worry, it's not at all confusing. So the quotient exponent law is basically the opposite. It's basically the opposite of the product exponent law. In the product exponent law, when you have the two of the same bases, which is the main point here, for any of the exponent laws to work, at least up till now, all of them have to have the same basis. So let's say a to the power of 3 over a to the power of 2. Well, as you can see, both of them have the same base, which is a, right? So therefore, we can use the quotient exponent law. So the quotient exponent law is basically the opposite of the product exponent law. So when we're saying a to the power of 3 over a to the power of 2, we can simplify it to write a to the power of 3 minus 2. And you can kind of get how this is the opposite of the product exponent law, as in the product exponent law you have to add both of their powers, but in this case you have to subtract both of the powers. So just like we did with the product exponent law, let's use some real numbers to justify this and show that it actually works, either if you do algebra or the quotient exponent law. So we'll use our same favorite number, 2. So 2 to the power of 2, 2 to the power of 3 over 2 to the power of 2, right? When you simplify this, we get 2 to the power of 3, which is 8 over 4, right? 8 over 4, we know that it's equal to 2, right? But there's a much simpler way to solve this. Since we know the quotient exponent law, we know that when you're dividing two exponents, which is basically something that has a power with it, when you're dividing two exponents, you basically just take the first power, the power on top, and you subtract it by the power on the bottom. So simplified, it would be, so I'm in blue, I'm going to do the more simplified version. It would just be 2 to the power of 3 minus 2, which makes 2 to the power of 1, or just 2. So as you can see, using both ways, algebra and the exponent law, we get the same answer, but the quotient exponent law just makes it a lot simpler. And when you're simplifying larger exponents, the quotient exponent law makes it a lot simpler to actually find the answer faster and in a more concise and prepared manner. So let's move on to the third exponent law. So the third exponent law is the bracket exponent law. So right here, the bracket exponent law is basically, it's very similar to both the quotient and the product multiplication law, but instead of adding or subtracting, you multiply in this case. And the bracket exponent law works when you have an exponent inside a bracket, so let's say a to the power of 2, and outside the bracket you have the whole a to the power of 2, so all of this, when you have all of that to the power of 3. When you have all of that to the power of 3, you can just say, using the bracket exponent law, you can say that a to the power of 2 times 3 is that simplified. So this in relation would be a to the power of 6. When you have this, let's use some real numbers again to make sure that this is indeed true. So we'll say 2 to the power of 3 inside the bracket, and this whole bracket to the power of 2. So using the bracket exponent law, we know that this is simply just going to be 2 to the power of 6. But using algebra, we can solve it, so just to make sure that the bracket exponent law does work. So 2 to the power of 3 is 8, and 8 to the power of 2 is 64. So 2 to the power of 6 here, and 64 is equal to 2 to the power of 6. And last time I checked, 2 to the power of 6 was 64, which means that the bracket exponent law does indeed work. 64 is equal to 64, meaning that the bracket exponent law is correct. So let's move on to our second last exponent law, and this is probably the easiest exponent law of them all. This is the zero exponent law. The zero exponent law is very, 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 very straightforward. All you have to remember is basically anything. So I'm going to write a is equal to anything, any number. So that would be any irrational number, any rational number. You know, you get it, so on, so on. If anything is to the power of 0, the answer is always 1. So this means if you have 2 to the power of 0, the answer is 1. If you have 1,000 to the power of 0, the answer is 1. Well, some of you may ask, the curious ones will ask, why is it always 1? Why is anything to the power of 0 always 1, not 0? Well, what you're basically asking is, like, a power is basically how many times you're multiplying the base by itself. How many times? So in this case, in a to the power of 0's case, you're basically asking that how many times are you multiplying a times a together? How many times are you doing that? Well, in this case, you're doing it 0 times. Well, if you're multiplying something by something 0 times, you're basically getting an answer of 1. Say for example, you have 2 strawberries, right? You have 2 strawberries, and someone says, I want to double your strawberries, but I'm going to do it 0 times. Well, how many strawberries do you have left? Well, it's still 1, because he has actually never doubled your strawberries, so you're left with an answer of 1. So now let's move on to the last exponent law, and this is the inverse exponent law. Inverse exponent law is basically, it's not really an exponent law used for simplifying, it's just an exponent law used for making something make more sense in a layman's term. So basically, the inverse exponent law works when you have a number, so a, to the power of a negative number. So let's say to the power of -2. So you're basically saying when a is to the power of -2 is, you're basically saying I'm going to multiply a times a. How many times? I'm going to multiply a times a -2 times. So you're saying I'm going to multiply this number -2 times. Well, this really does not make sense. So instead of saying a to the power of -2, we use the inverse, which is 1 over a to the power of 2, which is basically the same thing as we are using the reciprocal, because a to the power of -2 is basically a to the power of -2 over 1. But when we switch this around, put that up on top, and we flip the sign, making this a +2, we get instead of this, we get this. Oh, that was pretty bad. Sorry. Hold on. Instead of this, we get this. Okay, when we get that, it's basically the same thing, but it's inverse. Because, as I said, when you're saying you're multiplying a number by a number negative times, it doesn't really make sense. So you're using the inverse to make it make more sense. So those are all 5 of the exponent laws. I hope you enjoyed my video, learned something new. Please feel free to subscribe, hit the thumbs up if you enjoyed, if you learned something new.